Let's take a look at lesson 1.6. Particularly before we start, we're going to look at the bell ringer that comes from lesson 1.5. So as a review of some things with 1.5, I want to give you the two rules that were from lesson 1.5. So 1.5 had two rules for transformations. That's what it was about. The lesson was about parent functions and transformations, and I gave two different rules. Okay, so the first rule that I gave is what I call HIVO. I call it HIVO, and you'll see me write it like this all the time. That's an acronym, and what that stands for is that horizontal for your X transformations, so horizontal deals with X, are inside. Vertical, which deals with the Y, are on the outside. Now that's rule one, HIVO. Horizontal is inside, vertical is outside. Rule 2 from that lesson is that the inside lies. Inside lies, outside tells the truth. So inside lies, outside tells the truth. And so inside, just as a reminder, that's dealing with the X. The X is the inside, as you look up here, the horizontal, and the outside is the Y. They tell the truth. Okay, so when you look at these problems, you're going to start to be able to count up transformations by looking at how many numbers and negatives and things like that you see with the problem. And so I could count them up. This problem, I see 3 different numbers, and a negative in the front also counts as a transformation. So this problem, number 1, has 4 transformations. It has a negative, a 3 here that does something, a -2 that does something, and a +4. So there's 4 transformations. 1, 2, 3, and 4. 1, 2, 3, and 4. The negative in the very front counts as its own transformation. This isn't a negative as far as being in the front of anything like this one. This one is just a -2. So that is treated as one transformation together. This one is treated as 2 different transformations. And so going through the rules here, before I do that, if you look at number 2, this would have 2 transformations, a +1 and a -1. Those are 2 transformations. And number 3, we're taking the absolute value only. That is 1 transformation. So this has 4, this one has 2, this one has 1. Now let's check and see how these problems get changed. So on the lessons, I talked about how a negatives reflect. And so I'm going to have a little Q&A here. It's a reflection, and I want you to use the rules real quick. This negative occurs outside of this parenthesis. When I talk about inside and outside, I'm really referring to the parenthesis with F. That's the actual function you're looking at. This negative, it's occurring on the outside of this parenthesis. It's outside of it. So I want you to look up here and determine, is it horizontal or vertical if it's outside? So since this negative is on the outside, this has to be vertical, meaning it's going to affect the Y values. So it's a vertical reflection. So let me show you how you do a vertical reflection. What happens is all the values that are Y's just get swapped, negative and positive. So if I look at my graph here, I see 1, 2, 3, and 4 points. So these 4 points, what happened is the negatives, or the Y values, are going to swap. So this is a -3, -6. It's going to become a -3, +6. So I would go left 3 units and up 6 units, which is going to be off the graph somewhere. So that point gets shifted all the way up here. This point says -2, -1. So that -1 is what swaps. The negative affects the Y. So -1 becomes a +1. And so it would become -2, +1. And that spot is right. Whoops, that's not -2. Sorry, this is -2. And it's going to become a +1. So that point's going to become right there. That point will get shifted to right here. Whoops. So this point moved up here. This point gets moved to right there. This point here is 0, 3. Now what happens is the y changes, and it's going to become a negative 3. So this one's actually going to get reflected downward to 0, negative 3. That's where this point's going to become 0, negative 3. So if you haven't figured out what I'm doing, is I'm taking each one of these points and I'm just changing the y values sign, whether it be positive or negative. They just get switched. And so this last point would get shifted up. Instead of being a negative 1, it would become a positive 1. And so it would go right there. So this graph, instead of looking like this, would come through, and we go to this point, and it would keep going down until here, and then it would come up to this point, and then go this way. So that's how this graph would look if it only had the negative. Just the negative would make it flip vertically. Okay, now I'm going to erase this because there's 4 transformations that are going to occur. Actually, I have a better way of doing this one at a time. I'm going to shift this over, and I'm going to come over here to Desmos, and I'll show you. So here's our graph, and if I were going to do transformations one at a time, I want to take away these other ones so you don't see the whole answer. I just want to show you what the negative would look like. There's taking a negative. So all the y values just swapped. So this point got shifted up, this point got shifted up, this point got shifted down, this point got shifted up. The graph just reflects vertically. That's what a negative in the front does. So it's a vertical reflection, and we talk about what axis does it cross over. So when these points are getting shifted up and down, I just gave you the answer. What axis are we reflecting on over? Like what axis are we crossing whenever we reflect? What axis am I crossing right here?
The x-axis?
That's right. And so the way this would be written, if you were writing English, is you would say vertical reflection over x-axis. So that's the first transformation. The second transformation is that positive 3. And that positive 3, notice, is multiplying. That I say positive 3. I'm sorry, I shouldn't be saying that because that's going to confuse you with the negative bit. This 3 by itself, just the 3, is multiplying times f. F is in the place of y. What that is a vertical stretch. Why is it vertical? It's vertical because it is outside. This is on the outside, so it's going to be vertical. And it's going to tell the truth, which means it looks like it's multiplying times the f, and f again represents y. That just means we're going to multiply all y values by 3. So this is a vertical stretch. It's a vertical stretch by, and they would say factor 3, and that just means you multiply by 3. So now what's going to happen is all these values here, these points, the y value is going to get multiplied by 3. So let's just take just this one point. Right now it was a 3, and it got turned into a negative 3. But if I put the 3 here, now what's going to happen are all y values get multiplied by negative 3. So 0, 3 is going to become 0, negative 9, because my y value got multiplied by negative 9. At this stage, I think some students, it starts to click what's happening. If you see something on the outside, you perform the math to the y value. Outside is y, and you're just going to do whatever the math says. So this says a negative 3 times f. And if you think of f representing your y, that's saying multiply the y by negative 3. So this point here got multiplied, it got stretched and reflected to go down here. I took the 3 and we said 3 times negative 3. And again, the negative 3 came from right there. So it's 3 times negative 3 equal negative 9. And so my point became 0, negative 9. If you wanted to look at any other point in the graph, the same concept would happen. So like take this point. Right now, my y is negative 1. I multiply that by negative 3. Negative 1 times negative 3, 2 negatives make a positive. This just becomes a positive 3. So if you look, this point where it's hitting is 2 units to the right and 3 units up. This point right there is 2, 3. The x stayed the same, but the y got multiplied by negative 3. So negative 1 became a positive 3. So that's how you reflect this way. Now, why am I giving you this problem? It's because this is what you have to do on your ALEKS homework. Is they're going to give you graphs and they're going to ask for a point or for you to change points, stuff like that. And you just got to know, okay, that's on the outside. It looks like it's multiplying times that f. It's multiplying times the outside. That means I multiply that times the y. So now let me get into inside transformations. This -2 is on the inside of parentheses. So inside, according to rule 1, has to do with the horizontal or the x values. And the inside lies. So this looks like it's saying subtract 2 from all x's, but it lies. We're not actually going to subtract 2 from the x's. We're going to add 2 to the x's, which means this is going to shift right 2 units. It's going to be very tricky, but all the x values are going to get shifted right 2 units. So this point, you're going to notice, is going to move to right here in a second. This point is going to move to right there. This point is going to get moved to right there. So we're going to have a graph come through, hit that, hit that. Let's see. Maybe I'm telling you lies. Maybe I'm telling you the truth. Let's see. Check it out. I shifted my point over. So this wasn't exactly on the line. I didn't go 2 full units. It was right there. It should have gone 1, 2 like that, if I'd drawn accurately. But this one is on, and this one's on. Notice how the graph just got shifted right 2 units. Now, the reason you need to know you do the opposite on x is because inside lies. I tell a joke when we're in person. I say this. So I'm a male. Oftentimes males marry females, and so when they think about it, they say, hey, I've dated other people, but I broke up with them. They are my exes, but I married my wife. Now, why did I marry her? Because she tells the truth. Why did I break up with the other one? Because those exes be lying. If the exes lie to you, you break up with them. If the wives tell you the truth, that's who you marry. So just if that helps you out to think about it, exes lie, wives tell the truth. You get it? Wives sounds like wives. Yeah, so wives tell the truth, your wives tell the truth, your exes, they're lying, so that's who you break up with. Exes lie, wives tell the truth. And so now I'm gonna go finish off this problem. I have one more transformation. This +4 is on the outside of the parenthesis. So if it's outside, it's a y, and y's tell the truth. So this y value is gonna get added by 4, which is gonna shift the graph up 4, shift up 4. That's what this transformation is going to do. And so when I come over here and type it in the calculator, all these points that you see right now, let's just label a few points. I'll do these. These 3 points in particular are going to get shifted up 4 units. They're going to get moved up 4 units. So when I add that +4 on the outside, you're going to see this red graph get shifted up and the points get changed. +4, and notice how the graph goes through it. It's been shifted. So all in all, we had 4 transformations. What did the negative do? Very good. I heard it reflected, and it was on the outside, so it reflected the y values. Each y value of these points just switch symbols, whether they're positive or negative. Okay, what did multiplying by 3 do? Did that multiply the x's by 3 or the y's by 3?
I multiplied the y's by 3.
That's right. And did I subtract 2 from the x's here?
No.
No, because your x's lie. So you don't subtract 2, you actually add 2 to all x's. And so it went right 2. And then finally, that +4, is that inside or outside?
Outside?
Outside, so it shifted it up 4 units. Okay, so now let's come look at number 2. On number 2, I only have 2 transformations. And I'm just gonna erase just a little bit of this so I can see it a little bit clearer. Okay, on this one I have 2 transformations. All right, class, is this +1 on the inside or outside? Is it inside an x or is it outside a y?
Inside.
It's inside. So if it's inside, it's going to affect the x's, and it's horizontal. And according to rule number 2, inside always lies. The x's lie. So I'm not actually going to add 1. What am I going to do to my x's?
Go down 1?
You'd think down 1, but that would be a y-axis change. The x only goes left and right. So if I subtract 1, which way is it going to move it?
Left.
Left 1. This will be a shift of left 1. I forgot the right shift. I'm writing it the way you'd see it if you were taking a test or doing your homework. You'll say shift left 1 unit. And then here, is this inside or outside?
It's outside.
Outside. So outside is a y or a vertical, and outside, the y's tell the truth. So on the y-axis, going down, -1 would be down 1. So this is just going to shift the graph down 1. So when I come over here, I'm going to put this graph in. We're saying it's going to go left 1 and down 1. Again, I forgot the word shift. Let me write the word shift. There we go. So we're saying it's going to shift left and down 1 unit each. Does it appear to have gone? Let's check out this. Does it appear to have gone down 1, left 1? Or at this point, down 1, left 1? Any point you pick, if you go down 1, left 1, it would hit just the same on the other graph. So this point right here is -3, -6. If I went down 1 and left 1, from -3, -6, it selects it there. Here we go. There goes 3, -6. If I go left 1, I'm saying we subtract 1. If I go down 1, I subtract 1. Notice I did a lie on the x. I put -1 right here. Let's see how that point hits. This graph went down 1, left 1, and it hits it perfectly. So it wouldn't have mattered any point you picked. I could have started with 2, -1, 2, -1, and then you do your transformation. The x's lie, so I typed in -1. The y's tell the truth, so I typed in -1 here. And you'll see this point also got shifted down 1, left 1. So that's how transformations work. Inside lies, outside tells the truth. High-vo, horizontal, or x is inside, verticals outside. Let's talk about absolute value now. What does absolute value do? Very good. I paused it there, but back on the recording, what a student just said is it takes the negatives and turns them positives. And if it is a positive, it stays positive. That's right. When you're telling the truth, that's exactly what happens. So this absolute value is on the outside here. This absolute value is on the outside. So here's what I want you to know. If it's outside, it's a vertical, or it's dealing with the y's, and it's going to tell the truth. So basically, you're just going to find the absolute value of the y's. So how this graph would look is if I took the absolute value of the y's, as the student just said, the y values that are positive stay positive. So this is the positive. Remember, for y-axis, this is the positives, this is the negatives. The positive, the parts that are above the x-axis are going to stay the same. The parts that are below the x-axis are going to become positive. So like this is a -1 here. We would need to take the absolute value of this one, and this point, and this point. What's going to happen is this graph is going to get reflected to be all positive. That's what's going to happen. So instead of having 2, -1, it's going to become 2, +1. 2, +1. Because you take the absolute value of the y value. So this is counting by ones. That means this point is going to come right there. So this graph is no longer going to come downward like this. It's now going to get hit there. And then this piece, instead of staying at -1 on the y-axis, instead of staying at -1, it's going to stay at +1 up here. So all this graph is going to disappear. On this side, these negative values are going to become positive. So instead of being at -1, it's going to become at +1. So again, that would connect and this would go away. And instead of going down to -6, this value would go up to +6. There it is. So it become -3, +6. And so my graph would connect like that and just continue on forever that way. And all of this would disappear. Now that's what's going to happen. Let's see if I'm right or if I'm wrong. Hit the graph. Let me clear my ink. Voila. There it is. So notice from the first graph that whenever you take the absolute value, the negative portions disappear, but all the negative portions became positive portions on the y. So there was the original in the blue. You can see over here we have an overlap. Where the y's were positive, you have an overlap because those stayed the same, but the negative y's became positive y's. And so that's why we scribbled out this part of the graph a moment ago. This was taking the absolute value of the y's, is how we got the green graph. Now, what if I would have done the problem differently? On my next slide, I show, what if I would have asked the problem this way? Notice this time the absolute value, is that absolute value on the outside f, which represents y? Is it on the outside y, or is that on the inside? This absolute value right here. Yeah, is that absolute value right there on the outside or the inside of the function?
Would it be on the outside?
Okay, so outside was the previous problem that looked like this. Oops, that was supposed to be a vertical line. There we go. That's what outside looks like. When I talk about the function, I'm talking about the letter f here. This would be on the outside. This one is different. This one is on the inside of these parentheses. So this one's an inside transformation. And so what two things can you tell me if it's inside? From the rules I gave you on the previous slide. If something's inside, does it affect the x's or the y's? Something's on the inside. Is it going to change x's or change y's?
Y's. X's.
Let's go back and look because I'm hearing both. If it's on the inside, it's horizontal, changing the x's. Inside's horizontal. And if it's on the inside, it also lies. So what does that mean? This is what it means. We're going to be looking at the absolute value of x. However, because inside lies, instead of taking negative x's, so this is going right down here, the absolute value of x, what that transformation will do is it'll take positive x values. I'll just write it out, positive x values, and it's going to turn them negative. Now, why does it do that? Because inside always lies. As I said earlier, your x's lie to you. That's why you dump them. So let's take a look at this graph. This time I'm looking at the absolute value of x. So my positive x values are going to become negative x values. So I'm only focusing on these positive x values, and they're going to become the negative. So this part you don't have to pay attention to. That's going to go away. The positive x's are going to become negative x values. So this part will reflect, and instead of having these positive x values here, they're going to become negative. Let's see here, that's 4 boxes, so it'll be like 4 boxes out, like right here. Like this, and then it'll go that way like a sombrero. I guess I could have wrote it on this graph.
It is now the end of B-Rush.
It'll look something like this. Let's check it out. I have it right here. So there was our normal graph. When I take the absolute value of the x's, it takes the positive x's and it turns them and makes them negative x's. Now, why did the absolute value here take positives and make them negative? Why did it do that? Okay, I hear because of the absolute value. But does absolute value normally take positives and make them negative?
No.
No, so why did that happen? Why did it do something that's not normal? Why did it take positives and make them negative when normally negatives become positives? I'll give you a hint. It has to do with rule number 2. What was rule number 2? Inside always lies. Your x's are always going to lie to you. So absolute value normally takes a negative and makes it positive. But if it's on the inside, it's going to lie. And so it's going to take a positive and make it a negative because your x's are always lying. That's why this graph, it took the positives and it made them negative on the x-axis. The y's stayed the same. They didn't change at all. So that's how the transformations work. Now that was a kind of a long introduction, but it's just helpful to do that. I have some extra problems I want to take a look at just to make sure. I think it'll be helpful for you understanding how these work, and it'll be helpful for your homework. So what are the extra problems I have? This one, example 7a. This is all from lesson 1.5. Just kind of review. I'm going to hit this one more time. So this was at the end of the last lesson, but I'm going to hit it now just to see if we can understand better. Would you say that's on the inside or outside, this absolute value here?
Inside.
Okay, I hear inside. So when I say inside or outside, I'm referring to the parenthesis. Okay, so there's a function by itself. That's how we normally write it, f of x. This absolute value, is it on the outside of it or the inside of that? These right here.
It'll be on the outside.
That's on the outside. And so if it's on the outside, is it vertical or horizontal? Meaning, is it going to be x's or y's?
Y's.
Outside or y's. And will it tell the truth or will it lie?
It'll tell the truth.
True. So absolute value means we take negatives and make them positive. So we're going to look at our graph, and we're only paying attention to the y's here. We're going to make negative y's become positive y's. This is the only negative portion I see. It's the only negative y's. So this negative portion of y's is going to go away, but it's going to become positive portion. So you just make it reflect up like this. And this part of the graph disappears. Okay, here's a different one. So I'm just trying to let you be able to compare and contrast this. This time, these absolute values. And normally we have f of x like this. Did we throw those in on the inside or the outside of the function? This time.
Now it's inside.
Now it's inside. And if it's inside, is it horizontal or vertical? But meaning, is it going to affect the x's or the y's?
X.
And what do you know about your x's? Why did you break up with them?
Because they lie.
Because they lie. And so what this means is we're not going to take negative x's and make them positive. We'll do this. We're going to take positive x's. So we're looking on the x-axis now. Take positive x's and make them negative. So this negative portion is going to go away because we're going to take this positive and make it negative. So it's going to, that point will reflect over there. So it's going to look like this. Kind of like that. Okay, and on this one, I'll do both.
It is now the beginning of sea lunch.
So here, inside or outside?
Outside.
Outside. So if it's outside, that affects y's, and it tells the truth. So you would take any negative y and make it a positive y. So here's my negative. This would just become a positive y, something like this. And this would go away. Or for this one,
Inside.
over here, this one's inside. And since it's inside, it's the absolute value of x, and it lies to us, which means take a positive x, here's my positive side, and turn it negative, like that. Forgot to put the other green arrow on this piece. There we go. And so on this one, for the x's, both this piece would disappear again, and this part over here would disappear because you're just going to pay attention to the positive side. So that's how the two graphs would look. And I do have those on Desmos as well. There, this graph here. Ignore those points. There was the original. When I take the absolute value of the x's, it looks like that. And I forgot to do another one with the absolute value on the outside. Add that in right here. Absolute value. Oh, okay. So there's this one. With the absolute value on the outside, you take your negative y portion, you reflect it up to make it positive. Or on this one, you take the positive x's and you turn them and make them negative x's. And you wouldn't have the other pieces. So that's how the graphs look. That was a lot on transformations. Hopefully that helped you out. Today for 1-6, I'm thinking, what are we supposed to be learning today? So if I go to our class here, and I'll show you, don't forget how I've set up everything. The first thing you need to do is take your attendance. So you go to lesson 1-6. We're learning about function operations and composition of functions. Your objective is that you will be able to have the composition of functions and model and solve mathematical and real world problems. You will be able to compose multiple functions. That's bad English there. I should say the student will be able to compose multiple functions to model and solve real world problems. Make sure you take your attendance. You have videos and some links to help you out here. You will have to take a lesson exam and your ALEKS. These are going to be due Thursday of next week. But before I move on, I'm actually going to give you an introduction, just some extra things to show you what's going to be happening on this lesson. So 1-6, I'm going to skip the example 1 because I think you'll catch on to that pretty fast. But 1-6, starting here, a lot of students get kind of confused of what's happening. So just as a little teaser, I'll spend just a couple of minutes. What you're doing is this. You're going to be finding things, you might have seen this before, this type of writing, where it says like f of g. And I call that fog sometimes, although it's really f of g, which means you're going to be finding a function with another function placed inside of that function. So on this one, f of g, what that means is function f with function g placed inside of function f. That's a mouthful to say, but here's how it works. Let's say you have two functions. We'll call f of x, I'll keep it simple, and g of x as being 2x minus 1. What f of g means is you take your g equation and place it inside the f equation where x should be. So you're substituting. Normally, we write f of x. But what we're substituting in its place is g of x. So wherever you see the x gets removed and you replace g in its place. That's what's happening. Normally we have f of x. But whenever you have fog or goff or any of these things that look like f of g, stuff like that, what that means is instead of just having f by itself, you remove the x's and you put g's equation in its place. That's what's happening here. So on this problem, I'm going to remove f's x value, if you will, and I'm going to replace it with g's equation. So I'm going to get some space here. I'm going to rewrite this one more time with a little bit more space. So f's equation by itself, I wrote as x, and I'm going to leave some space, plus 7. G's equation is 2x minus 1. So here's what happens when you want to find f of g. I'm looking for f of g. What's going to happen is this x is going to get removed. Whoops. That x will get removed, and it's going to get replaced by, no, come on, move. 2x minus 1. It's going to come in and fill a spot. That's what's going to happen. Now, right now, you might be going, what in the world is he doing? He's dragging around everything. I can't follow this. So I have a technique. To find f of g, here's what I do if I were you. I stack my equations. So I go with the first letter, which is f, and I write its equation. Don't even worry about the f of x right now. Just write f and put the equation, x plus 7. And then you go to the next letter, which is g, and you put it underneath it, 2x minus 1. Now, to help yourself out, draw an arrow, put a parenthesis around the bottom equation. So I wrote it in order that I saw, f of g, so I wrote f and then g. That O just means you're going to place the g inside of that. what's going to happen is G's equation is going to go inside of F's. So I'm going to put a parenthesis around G's equation and draw an arrow into the X. This is kind of a visual for what's happening. This equation is getting substituted into this X, which means f of G is going to be, instead of just X here, it's going to be 2x minus 1, and I'll keep the parentheses just in case I have to not multiply or something like that. 2x minus 1 plus the 7. No, I'm going to change colors. Plus the 7. So notice only the x got removed, and it got replaced by G's equation. And if you can simplify, you do so. So in this one, I have the parentheses I don't need anymore because there's nothing to multiply with. Parentheses mean multiply. So I can drop the parentheses. But I have a minus 1 to plus 7. Minus 1 to plus 7 is going to be 6. So that means f of G of x is equal to 2x plus 6. That's my answer right here. Why is that? Because this was the same thing as 2x minus 1 plus 7, which equals 2x plus 6. So a lot of students are going, what in the world did you just do? Well, I'm going to show you all over again. Okay, I'm going to take this away. I'm going to change one thing. This time, what we're going to find is what I would call Goff. G of F. We're going to find Goff this time. So now if you're finding Goff, what that means is you start with the letter G. So I first write down my G equation. G is 2x minus 1. Underneath it, I'm going to write my F equation. That's the next, that's the order, which is x plus 7. Now to solve it, you start with your bottom equation, put a parenthesis around it, and you draw an arrow directly into the x. So this time, what happens is I get 2 times the parenthesis, x plus 7, minus 1. See what happened there? The x came out and got replaced with f's equation, x plus 7. Now this time, that parenthesis means multiply, and I have a 2 to multiply with it. So to simplify, I would distribute, and so I'd have 2x plus 14 minus 1. So Goff on this equation, g of f of x is actually going to equal 2x plus 13. Now I want you to compare this answer with the previous. Is g of f the same thing as f of g? Did I get the same answer or a different answer?
Different answers.
Different answer.
Different answers. So that can happen. You can get 2 different answers. So f of g does not actually equal f of g, or g of f does not equal f of g always. Sometimes they will, sometimes they won't. Now there's one more thing you might see that happens. So I'll copy this problem one more time. Sometimes you'll get what I call lucky. And they're going to ask stuff like this. So erase this. You'll get lucky and you'll be asked to find it with just a number. Let's say, what is f of g, but instead of putting an x here, they put like a number, like 4. And in that case, I think you're really lucky. Because here's what that means to do. We stack. That's my technique I'm going to give you. So I'm going to write the f's equation first, x plus 7, because it came first. Then I write my g equation, 2x minus 1. And then I write the 4. If you have a number, you then write the 4 underneath all that. I'm going to put it directly under the x. Yes.
I'm sorry to interrupt. I'm about to disconnect to the Wi-Fi. Do you think
Okay, so picking back up, I stacked f on top of g, and then I put the number 4 at the bottom. Now, I said you're lucky, and you might be thinking, why am I lucky? It looks like I have 3 stacks. Isn't that going to be more work? No, not with a number. A number always shortens the work. Because here's what happened. you substitute the number in first. And so just to keep the rules the same, I'll put a parenthesis around it. I'm going to substitute, which means this becomes 2 times 4 minus 1. So no longer an x, it's now 2 times 4. Now what is 2 times 4? 8. Okay, so 2 times 4 is 8, and I subtract 1, and I get 7. So that means g of 4 is 7. To find f of g of 4, I now take that 7. Let me get a different color that I haven't used yet. Here, let's get purple. I'm going to take that 7, and I'm going to substitute the 7 in to this x. So this goes right here. And so I'll have 7 plus 7. 7 plus 7 is 14. That would be the answer. F of g of 4, brackets, is going to be equal to 14. Now, I think that's easier than dealing with all the x's, just plugging in a number. So just to make sure you see it enough times, I'll do it one more time, but this time we're going to use Goff. So instead of f of g, I'll do Goff. Come on, smartboard. Okay, here we go. So I'm going to erase this. And so this time, what if you had to find g of f of negative 2? If you had to find this, how would we start?
Write down g
Very
equal
good.
to 2x minus 1.
Great.
Then equals to x plus 7. And I'll put the negative 2 at the bottom.
Great. And so now it becomes a substitution game. You just substitute as you go up. This goes in that place. And so f of negative 2 would be negative 2 plus 7, which happens to be 5 if I'm doing good math. So that's 5. And so now I take my 5 and I plug it in right here. And so this would become 2 times 5. Whenever you substitute, always substitute with parentheses, just to make sure you do your math right. 2 times 5 minus 1. So 2 times 5 is 10. Subtract 1, I'm getting 9. That means g of f of negative 2 equals 9. And that would be your answer. So most of your homework and things like that are going to be going over this. If you watch those videos, I'm going to go in detail, give you tons of different examples. The one thing you're going to need to really watch is domain. And so that's why I did all that. I just wanted to show you what was happening because I don't like the order of the lesson. The order of the lesson starts with domain and then it gets into the algebra. I wanted you to see the algebra first so you have an idea how to do the algebra before you get to domain. Domain for composition of functions can get tricky. And so here's how you do that. So this whole slide is looking at fog, f of g. And so as we were just saying, if you had f of g, normally that means you stack it, not normally, this is the way we'd solve it. We would stack f on top of g. We'd go in that order. When you find domain and range, and this is the way Alex presents it when you get to your homework, you need to make sure you're looking at the bottom equation first. So I'm looking at g's domain and range. You start with the bottom. That's where we start. So I'm looking at domain and range of g. And then you go to the f second. So whatever on top goes second. So here's f's domain and range. Are you with me so far? I have domain and range for g. I have domain and range for f. Are you okay with what I have so far?
Yes.
Yes, thank you. Okay. You want to start with the bottom equation. So I start with this one. And what I'm going to do is I'm going to go from 1 to 2 here by looking at how can the range of g connect to f. So I'm going to add extra connections. From the range of g, I see the number 6. Does the domain of f have a 6 in it?
Yes.
Yes. So I'm going to connect these here. So 7's the next in the range. Does this have a 7?
No.
No, so 7's going to be out. Does it have an 8 over here?
Yes.
Yes. Does it have a 9 over here?
No.
No. So here's what that means. To get your domain and range, you only follow, if you want to call it like train tracks, if you've ever played Ticket to Ride, you only go off the numbers that are totally connected all the way across. So for example, this 6 connected to this 6, so you go trace all the way back. This 2 is going to be a good number. And this 13 over here is a good number. These are good numbers here. And this 2 is a good number here because they're connected all the way across. Which means this 2 is going to be part of the domain, and this 13 is going to be part of the range. G's domain, F's range is how you're going to get these values and plug in from there. Okay, this is my other bridge across. The 8. I got 8 from 2 places. I got it from 1. So if you didn't notice that connected there. 1 connects to 8, and 3 connects to 8. So these are my 3 good values. 5's out because it connected to 7. 4's out because it connected to the 9. And neither one of those had a bridge across. So those numbers are out. So my domain is 1, 2, and 3. My range, I follow this connection all the way across, is 13 and 14. These are my good numbers. These are out. So my range is simply 13 and 14. So that's how domain and range work when you do compositions. You need to write it out in this order. You start with the bottom, and you write its domain and range first. And then you go to the top equation, and you write its domain and range. You look for the connections between number 1's range and number 2's domain. You just try to connect it all the way across. So you go domain, range, like this. This range has to connect to this domain. Only the ones that have connections all the way across are good. So since only 6 and 8 counted, you look back, where did 6 and 8 come from? They came from 1, 2, and 3. So those were my domain. Over here, 6 and 8 pointed to 13 and 14. So those were my range. So this would be the domain and range of F of G. Right here. So I just want to kind of go over that. When I go through the lessons, that's how I'm going to solve. So I'm going to first start with this one's domain and then work our way up through here through the videos. But that's what I have for today. Reminder, you should come to Power School Learning. There are 4 things. Make sure you've taken your attendance. Watch those YouTubes. I'd recommend using the completed copy with you at the same time. So you can kind of go back and forth and work on the DOLs as you work. Once you got those answers, take your DOL or the lesson quiz, and then you'll have Alex homework.